Okay, this is 6.4, compound inequalities. First of all, compound, I should back up. Compound, definitely means, just like in, grammar, compound sentence means that you're combining two complete sentences and you have an and or an or, I guess, or a but that kind of combines those two sentences, but usually an and or an or. Now, these words in math, they actually mean something as well as in the real world. The word and means that both parts have to be true. So I'm going to go ahead and say that. Both parts must be true. With an or, that's not the case. Only one part needs to be true. You'll know what I mean by part in a second. The other thing that's true about an and problem is that we're looking for points in common. That's really what we're looking for. Points in common. Points overlapping is another way to say it. Overlapping. And this one is not points overlapping, it's just the combination of the two graphs. Combination of the graphs. We call it a union. Okay, mathematical words, a union. It's putting two things together, just like in marriage. Put two people together, whatever that is, that's your union. With an and, it's not called a union, it's actually called an intersection. So whatever points are in common, just like when two corners meet, they call it an intersection. They share a little bit. They share a little bit of the road, okay, a little bit of the street. So same thing with an and. They share some points, and whatever those points are that they share, that's actually the solution. All right. So we want to graph the solution set. Oh, I know. I wanted to add a really nice number line to this. So give me 1 second. I'm not going to worry about it right now. All right. So what we want to do is, see if I can find a line here. Okay. I'll just use a line at least. So graph the solution set. So we start off with a nice number line. And I'm going to put one down here too, so I have it ready. All right. So now what I'm going to do is I'm going to go ahead and graph what I've got here. So I usually just put some points in, if that's -2 and 3, like maybe I'll put 0 in there. I'll put 0 maybe right here. And then I'll have 1, 2, 3. And then that's -2, so we go to the left. So, all right, let's do these one at a time. So the one on the left, it says z is less than or equal to 3. So that would be a closed dot, remember, and it would actually go this way. Actually, it would go this way the whole time. So that z is less than or equal to 3. Then we would graph the other one. This says that z is greater than, the one on the right, z is greater than or equal to -2. So that would be a closed dot right here at -2, and that would be going that way forever. Well, since it's an and problem, we'd be looking for, hey, where do these points overlap? Well, they would overlap, obviously, right in the middle here. So the only solution to this that's actually accurate is all of this region here, everywhere from -2 to +3. And they overlap, including those endpoints. So the answer to this, the graph, is just the blue graph. So the blue graph is everything from -2 to 3. And that would be your answer. The answer is the graph itself, not the red at all. The red was just a way for us to get the right answer. And so we were just looking for points that are overlapping. Okay? Now the bottom part. Let's do this one. This one says that y is less than -1. So first, let me put in some coordinates again. So I got 0 right here. See, I have 1 right there to the right, -1 to the left. Okay. So it says y is less than -1. So that's an open circle. Remember, there's no bar underneath it. And I go to the left. This one says y is greater than or equal to 1. So that's a closed dot. And it's greater than or equal to 1. So it goes that way. Now, because this is an OR problem, we're not looking for points that are overlapping because there aren't any points overlapping. So we're going to be okay with that as our answer. It's okay for OR problems to go out to the left and to the right. And then we just say that that's the answer. Okay? Next example, we're going to actually solve something here. So solve, and then we're going to graph the solution set. So m plus 3 is greater than or equal to 5. We're going to subtract 3. So we subtract 3 from both sides. That'll cancel out. So m is greater than or equal to 5 minus 3, which is 2. And then we're going to come over here to the right, and we're going to solve for m. So they're usually just little easy inequalities to solve for. So we subtract 3 from each side there. So m would be less than 4. And then there's a little and in the middle, so I'll just kind of write that below. So now I'm ready. I need a number line. So I get a nice number line. So then I'm ready to graph. Okay, so I've got m is greater than 2 and m is less than 4. So I'm going to put a couple, whoa, don't want that. Sorry. Oh boy, I want that thing. Give me 1 second. Get rid of that dude. Okay. And let me make this a little straighter. Actually, I might need to get rid of this line too. It's a little crooked. Okay. So let me make a new line here. Make it black. All right. Okay. So now let's start graphing. So we got 0 here. We got 1, 2, 3, 4. Okay. So m is greater than or equal to 2, so that would be a closed dot, and it would be going this way. And m is less than 4, so open circle would be going this way. And you might be able to visualize where they would start overlapping, because if this one went this way forever, and this one went this way forever, they would overlap right in the middle here. So sometimes you can just go right to the answer without drawing, a graph on each side and then coming up with where they overlap. So we might be able to tell that they overlap right here. Okay? If that doesn't work, then you need to do the separate graphs. So you would have, this graph would go this way forever, then this one would go this way forever, and then you would go, oh yeah, they would overlap right in the middle, and then you would come up with that particular answer. Okay? Same graph. But I'm going to go ahead and erase that. Okay, so next problem. Solve and graph. Well, the and problems are the only ones where you can kind of squeeze the inequalities together like this. Notice they're all kind of squeezed together and there's no word like and or in between. The ands are the only ones that you can do this with. So whenever they're squeezed together, it's an and problem. So we're going to just solve for the variable. We're solving for b. So we just have to add 4 to all 3 parts. So that cancels out. And in the middle, we have the b all by itself. And we just keep those signs the same. 2 plus 4, that'll be 6. And then negative 6 plus 4, that's negative 2. And then we're ready for our graph. So we're going to make it a little number line. And we're going to go ahead and graph. So I'm going to put maybe 0 right here, and then negative 2, and then 1, 2, 3, 4, 5, 6 over there. And what this says is you read it from the b. It says b is greater than negative 2. So that's open circle. So b is bigger than negative 2, greater than negative 2. And at the same time, it's less than 6. So that means open circle, it's also less than 6. All the numbers that are bigger than -2 and less than 6 are those numbers right there. So that's your answer. All right, next one, solve and graph. Well, we try to isolate the variables. So we got to add 3. Add 3. This one over here, we're going to subtract 5. So we add 3, we're going to get k is less than, it's going to be -4. Over here, we're going to cancel that out. That's going to be k is greater than or equal to 3. We're going to make a nice number line. Let's see. Nice number line. And then we're going to go ahead and plot our solution. So we have 0. We got -4. So I'll put a spot for that. And then I've got 3 here. And this says k is less than -4. So that's open circle because it doesn't have a bar underneath it. It goes that way. Or k is greater than or equal to 3. Closed dot goes that way. That's our answer. So it's okay that they go out to the right and the left and they don't have any points in common because that's an or problem. If this was an and problem, we'd be like, oh man, this is not good. They don't have any points overlapping. If this said and in the middle, then we actually would say we don't have any points in common, so we'd say no solution. So it actually is really important, the and or with these compound inequalities as far as the answer goes. Okay? Last problem. Application. Cookie. A cookie contains 9 grams of fat. Okay? If you eat no fewer than 4 cookies and no more than 7 cookies, how many grams of fat will you consume? Well, this is just an example of how you can write an inequality to represent how much fat you're going to have. So let's say the amount of fat you're going to have is x, the number of grams. X is the number of grams of fat. And so you're going to have 4 cookies here at least. Okay, so we're going to have greater than or equal to, x is greater than or equal to, because you're having no fewer than, so you're going to have 4 cookies or maybe more, so x is greater than 4. And then every one of those cookies has 9 grams of fat. So you're going to have to multiply each of those cookies times 9. And then you might have 7 cookies, but you're not going to have any more than that. So no more than 7. So you're going to have less than or equal to 7 cookies. And each one of those cookies is going to have 9 grams of fat. So that's going to be 36 grams if you were to have the 4 cookies, grams of fat. And then if you want to have 7 cookies, then you're going to have 63 grams of fat. So this inequality shows the amount of fat you're going to consume. You're going to consume between 36 and 63 grams of fat if you have that many cookies, from 4 to 7 cookies. Make sense? Cool.